Okay, so now we're in chapter 10. So this is 10.2. And this is about correlation. This is about to see if there's a relationship. You ask two questions, especially two questions with numbers. Okay, and we're going to find out if there's a relationship between the two of them. So like this picture way over here on the right, these would be like data points. If I ask two questions, say like how much money do you make and how many pairs of shoes do you own, something like that. I've asked two numbers questions, and then each person gets a dot. So their two gets clustered together, like in this example down here. This person answered 4 magazines, 6.2 hours of reading. They get their own X and Y coordinates. They get that in parentheses. And then they get their own dot. So each dot actually represents one person. So in your project, for example, you ask 30 people two different numbers questions, then you'll be able to do this. You'll be able to make a list of 30 of these and put them on there. Now, if they go up like this, well, I kind of see a trend there. You know, the more money I make, the more shoes I have, or something like that. I can see a kind of general pattern there. Or maybe it's the more kids you have, the less free time you have. Okay, that's a general trend as well. If it's like watching TV versus age, everybody knows how to watch TV. Old people can even manage it. Okay, so that just is everywhere. All right, so this definitely has a pattern to it. And this has a pattern to it, and this does not. Now, R value tells you how much pattern there is. With a positive R value, it's going uphill. You can see that it's basically a line, not perfect, but it's a line uphill, and that's got a positive R. This one goes downhill, and that's a negative R. But they've got a pattern. This one, it's got no pattern whatsoever, and R would basically be 0. So R is just going to tell us whether or not there's a pattern. R's are only ever between -1 and +1. You're never going to get an R value of like 7 or anything. It's going to come out as between -1 and +1. And +1 would mean it's a perfect line. This is not a perfect line. This is a little bit wiggly line. Okay, but I can definitely see there's a line there. This is a perfect line too, but it's a perfect line downhill. And this is not quite a perfect line. So our R's, an R here and an R here, are not going to come out as a perfect 1. Maybe this one will come out as like a 0.98, and this one will come out as a negative 0.93 or something like that. I'm just making up numbers. Okay, they're good numbers. 0.98, that's like right here. Negative 0.93, that's here. Maybe this one didn't come out as exactly 0. Maybe it came out as 0.23 or something like that. Okay, it's in the bad zone, somewhere in here. There's a cutoff between the bad and the good. And I've drawn a wiggly line in here because there's a whole chart for that. Okay, I put one of them up there in your files so you can look at this chart. But anyway, that's how we're going to know. First, we have to get R. And then once we get R, we're going to look at the chart and see, is it into the bad zone, or is it in the good zone over here, or is it in the good zone over there? Okay, so then there's my example. So I take all of these and I put them in list 1. So stat, edit, and then in list 1, I'll put these 7 numbers. And then I go over to list 2 and put these 7 numbers. And then I second quit to get out. And then I go into stat, tests, linreg t-test. Okay. And it gives me a whole bunch of stuff. It says A, it says B, it says the sum of the x squared, it says all sorts of stuff. But eventually it says R. It also says R squared, but I'm going with R. 0.28 0.755. I'm not sure if the calculator gives me something slightly different. That's in the notes. I give you the whole longhand way of doing it, old-fashioned, with all of the numbers and how they have to used to have to do it before. We're not going to do that. That formula takes forever. A whole line just to write the formula down, let alone use it. Okay, but that whole calculation is what the calculator just did, and it gave me R. So first, I put the numbers in. Then I do Linreg t-test. Then I get an R off Linreg t-test, and then once I've done that, I go to my chart and I find out if 0.2815 is a good number or a bad number. So go to the chart. It says N in this column. 1, 2, 3, 4, 5, 6, 7. Okay, so I go down to 7. And then we're never going to use this 0.05 column because the industry the 0.01 column, because 0.05 is the industry standard. So I'm always going to go down this column right here. So 7, 0.754. Okay. There's 0.754 right there. There's negative 0.754 right there. And 0.2815 is definitely in the bad zone. Okay, so not correlated. Because it's in the bad zone. All right, well, if I look at the dots, those dots that match up with that, it's mostly a line. It's kind of a line going through there like that. Except for maybe this one. This is an outlier. Okay, maybe whoever was taking the data accidentally copied down the wrong number, or maybe it's just someone who's very, very strange. This is some little lady. She buys a whole bunch of magazines, but she never reads anything. Okay, so however that works out, there's this one point, and if that one point wasn't there, all right, that one point is this one. She buys a whole bunch of magazines, never reads anything. If I take her out, maybe it'll be correlated. I mean, she's the problem. Okay, so I have to go back into lists, into list 1 and delete the 9. Okay, and then go into list 2 and delete the 4.3. And then run it again. So I go back to, once I've done those, I go stat, test, Linreg t-test, scroll all the way down until I get R, and I get 0.8666. All right, is that good or bad? I've erased my good, my cutoff between good and bad here. And the reason why is because I got to look it up again. Okay, last time it was 0.754, but that's when I had 7 data points, and I've erased one, so I don't have 7. I go down to 6 and 0.811. Now there's my cutoff. Negative 0.811, positive 0.811. And this number is into the good zone, so this is correlated. All right, once I got rid of the outlier, it is actually a correlated set.